Hello. This is an example of a DC nodal analysis analytical problem of level 0. So let's get started. Overlooking the circuit, we have a total of 4 nodes, and I don't see any control variables, but we have a reference node on the top left, and then 3 labeled potentials at V1, V2, and V3. So to determine how many equations you're going to need to solve for these, we're going to take the total number of nodes and subtract the reference node. So we have 4 minus 1, and we're going to need 3 equations. To start writing these equations, first step I always do is look at the circuit to see if we can find any voltage sources. And I do see one at the top, V1. Its positive terminal is connecting V1 potential with the negative terminal at the reference node. So to get the equation for that, we have V1 equals V1. Next, let's go to V2, and looks like we need KCL for this. Let's start with the current from V2 to the reference node over R1, and using Ohm's law, we know that that would be V2 minus 0, but we can ignore that, over R1. And we're going to add that with the current going from V2 to V3 over R3. So again, using Ohm's law, we have V2 minus V3 over R3. I'm going to set all that equal to 0. Next, let's look at V3. Let's find the current going from V3 to V2 over R3. So Ohm's law again, we get V3 minus V2 over R3. Next, let's go over the other resistor, current from V3 to V1 over R2. We're going to get V3 minus V1 over R2. And lastly, we have a current source going from V3 to V1. And the current source is going out of the node, so that's going to be positive. So we're going to add I1, set all that equal to 0. Sweet. And now it's asking us to write the equation for the sought variable in terms of V1, V2, and V3. If we look at the circuit, V naught is the voltage across R1 on the left-hand side, with the positive terminal on the bottom, the negative terminal on the top. So all we need to do is subtract the positive terminal potential with the negative terminal potential. And positive terminal is V2 minus the reference node potential, which is always 0. So it's just going to be V2 minus 0, or V2. Sweet. Thanks for watching, and I hope this helps.